So, what I wanted to discuss with you today is innovation through artificial intelligence applied to Formula Student. But you'll see that the conversation here is not about AI really. You just think bigger, dream bigger, and go accomplish stuff around the world. Okay, so this is the theme that we're going to be discussing here. So a little bit about what the whole mindset that I wanted to cover here is the following. Usually in engineering schools, particularly here, but in many places around the world, we are taught how to think in 10% increments. So usually we're learning to do something 10% better. And this is what I was taught in engineering. This is what I was doing throughout my entire Formula Student days. And it's a shame because there are other places in the world, and I had to go travel abroad to see all of that, that we are taught how to think in 10x. So it's not how to do a process 10 times better, but instead it is how to do a process, 10%, instead of 10% better, it is literally 10 times better. Listen to what I'm saying, 10 times, and it is possible. Most of the things that you do on a day-to-day basis in engineering, you could be doing it actually 10 times better. But there's something else. I moved to San Francisco through MOVEdot. And there, we're not taught how to think 10x. We're taught how to completely imagine how engineering is done, how humanity even lives. So this is the 1000x improvement. So you're rethinking completely everything that you do. Or you are finding the areas in your life where you can really achieve this kind of improvements. And I will give you concrete examples to highlight everything that we're discussing here. Okay, a little bit about myself. So I'm also a Formula Student guy. I did Formula SAE in Brazil for 5 years. It was basically, I didn't study engineering. Basically, I studied Formula Student. It was great. And I was the head of, or I was first the member and then the head of suspension and vehicle dynamics. So I have a similar background to you guys. I was here in all of these competitions. As you can see, based on the quality of this picture, it was a few years ago. So I joined the team in 2013. The car broke during the endurance event, unfortunately, very sad. We competed in 2014, once again, very strong car. We broke down during endurance, and there you go. So these were the first 2 years. But then, the year after, now I became the head of suspension, our team had one single objective in our entire lives, come to the competition and win it. And it was not easy. We had a very good car, but then 2 things happened. First is that our engine broke 5 days before the competition. Basically, it exploded. So we had to go find another engine, buy it, and replace it 5 days to the competition. And then the second thing happened. We came to the competition and the engine broke again. So at that time we didn't have the time to go find another engine. So we had literally to open the engine back at where we were staying and then literally manually clean the engine, rebuild it entirely, and we won the competition. It was amazing, we had great results. This was 2015. And you'll see that how throughout my career I'm progressing from 10% to hopefully 1000x, and I want you to see all of these examples throughout my career to make this very concrete. So we won in 2015, tried to go to the US, unfortunately didn't find the money. We had to win again the year after, and then we went to Michigan, which is one of the biggest competitions, at least here in the Americas. There, I was this is us in the US with our team, very focused as well. We knew that from the perspective of the car, we would not be very competitive. Of course, we don't have as much money. We didn't have a great project, at least compared to people outside, to teams outside of Brazil, which is a shame. But we knew that we could do very well in design presentation. And here I am presenting to Mr. Ruel during the presentation as well. I wasn't, well, yeah, spoiler, I worked at Optimum, but I was not working at the time. And then we had one goal. We wanted to be the best that we could possibly be in design. We worked a lot for that. Obviously on the car as well, but we knew that there we had a chance. So this was very good. Guys, just by doing very well in Formula Student, going to the US, I left this competition with basically 2 job offers in the United States, one of them being Optimum G. I picked Optimum G, and then after that, I moved there. And why? Just because a random guy from a city in the countryside of Sao Paulo decided that he wanted to build a race car, because it seemed like the most challenging project in university, and I decided to invest time on it. I decided to really improve the systems in the team, and there I was getting a job offer to go to the United States with an amazing opportunity with Optimum G. But this is something interesting. Remember that I said that I wanted us to have the best score possible in design? We did well. We went to the finals among 140 people. We finished, I don't remember if 7th or 8th, among 140 people from abroad, which is very good. And take a look here, suspension. This is the one that I was presenting. I got the highest score of everyone. But then the main point is not that I got the highest score, and we can even talk about how I was able to get the highest score. But take a look, so 22 out of 25 over here. Now, take a look at the bottom. I think this proves a point. Take a look at creativity of our team. What was the score? It was 0. So I had the best execution possible, but 0 creativity. And this is a lot of what we see here. This is a lot of what we see in engineering schools more broadly. Why? Because we're just trying to improve in 10%. We're just trying to optimize a system instead of really rethinking how things are done. So I think that this disparity between 22 and 0 is a good mindset for us. Of course, here we don't have as much resources. We need to just make the thing work. But yeah, we can find as many excuses as we want. But we really need to unlock something in our minds to start thinking more creatively. So, just to finish a little bit of the story in school. So, I got these job offers, I worked for Optimum G, and here I was doing racing around the whole world. So, you can go a long ways if you're just pushing very hard and pursuing your dream. My dream became to become one of the best performance engineers in the world in professional motorsports, and I got the opportunity. I was working in championships around the whole world, and all of this coming from Formula students. So I hope that this is good inspiration for you guys, because I'm sure that many of you want to do not necessarily this, but possibly something equivalent, to travel the world and show people how well you can perform as well. It's not because you're just a random dude in an engineering school that you cannot do amazing things afterwards. And there's something in consulting, which is you learn a lot from many different fields. So at Optimum G, I was learning pretty much everything. I was going to racetracks with race cars. Here is a test lab for tire testing. I was writing all of the procedures with the rest of the team, attending these events. This is us at an OEM customer, basically teaching them how to test K&C, so kinematics and compliance rigs with the vehicles. So I was learning about all of the different areas, and I was really passionate about it. I know that I'm speaking very fast. Is it possible for you guys to follow everything? Okay, great. Cool. But then something started clicking, which is, let me show you this. I started watching these videos over here. This is called Y Combinator. Does anyone know Y Combinator? Please raise your hand if you know. Okay, so 2 people. This is a shame that here only 2 people know about Y Combinator. So Y Combinator is basically the biggest startup accelerator in the world. So Airbnb went through that one, Stripe went through that program, Twitch went through that program, and dozens or hundreds of other unicorns, which are basically startups valued more than $1 billion. And I didn't know about this either, but I started watching this and I started getting addicted to it. And guys, everything is free of charge. There's no such a thing as things only happen in San Francisco. They are in San Francisco. Because they post everything. Like this is Sam Altman. This is the CEO of OpenAI. Today, I was building this presentation 1 hour before coming here. 2 days ago, they just posted a conversation they had with Sam Altman, and you can just go watch it for free. It is just insane. And this is their YouTube. It's called, you just search for Y Combinator. But then this makes you get thinking and makes you start thinking, okay, what kind of 10x can I do? What kind of new technology, new solutions I can create? This is when I started MOVEdot. So MOVEdot was founded 2.5 years ago, 2014, and we were set to create a new technology for the automotive industry. We had no idea what this technology would be. We just knew, okay, AI is starting to pick up, the technology is becoming good enough for engineering workflows, and we love building cars. How can we connect both? And then we started this cycle of every startup picks an idea. There is no magic idea. If one day you want to start your own project, your own company, you will pick one idea, it will be the wrong idea. I am 100% convinced. But you just have to keep building, you just have to keep pursuing it. And then adjusting and pivoting, as we call it, as needed. So I picked one idea. I was training surrogate models or machine learning models to model vehicle behavior, or maybe brake performance, or brake temperature models. But neither of these really picked up. It was not scalable, it was hard to sell, and we kept evolving until we found today's product. But everything started from this, and everything starts from one idea and then iterating on top of this idea. If you did not take notes of Y Combinator and you didn't open it on your phone, you really should. This is gold. Everyone in this room should know about Y Combinator and watch this video. So please go ahead, take notes, search on YouTube or on Google, Y Combinator. So I started watching this. I started getting these ideas flowing. And then, guess what? I picked one idea, I tried it, it didn't work. I tried another one, it didn't work. At some point we found something that worked and people started paying us money for new technology, which is a very good feeling. And guess what? We were relentless. We applied to this program 6 times, or 5 times, and we failed. On the 6th time, we got in. So we were approved in Y Combinator, we moved to San Francisco, we received investments from them. We got to hear from the biggest CEOs in the world. This is Brian Chesky, the CEO of Airbnb. This was one of the conversations that we were having there. And then this is a picture like Backstreet Boys, but it's just us raising some money from investors. And look how cool, going from the car braking and endurance all the way to raising a couple $1 million in investments as a random guy from Brazil. And it's a great feeling, and everyone can do that because it's basically all of this information is free of charge. You just have to have the right mindset. So we spent a couple of months at Y Combinator. It was great. We learned a lot. And in the end, it's just so simple. It's pick one idea, you're going to be wrong, keep trying, keep iterating. Don't hold the idea to yourself. Go speak to the world, because probably it's not even the right idea. So let's try to get feedback from people and try to sell it. Don't never build a product for a year, 2 years before you show someone. No, you're only allowed to work on a project for 3 months before you're showing people. Ideally 3 weeks, or even more ideally 3 days. Even if you don't have the final version, just go show people. Let's hear how bad this idea is so that we can learn, we can fail faster, we can learn faster, and then land on the right idea. So it's the same thing. Now let's try to apply all of this startup mentality to Formula SAE. What should you do? Go design your car, design a very poor first version. Go show to your old members, go show to your professors. Don't wait 6 months until it's too late for you to change. No, just go show people, show to other teams. They will not be able, there's no such a thing as copying. Like, you are so focused on your project, no one will have enough time to really copy you. So go show to people, go learn, go iterate, go pivot. So this is how you apply everything that we learned at Y Combinator in Formula Student. And I can only guarantee that you're gonna have better success by doing so. Cool, everyone following so far? Great. I know I speak a little fast. Okay, and then the coolest thing, now we have real people paying real money to MOVEdot for the technology that we created. So take a look here, MOVEdot at a race car. This is McLaren, IndyCar, posting about MOVEdot, how they are using AI, our AI and AI agents to improve their operations. And we have dozens of other customers, and we have maybe 150 engineers or 200 engineers already using our platform. And this is how we keep pushing and we keep growing. And guys, please notice that the difference in this whole trajectory, or the difference between people who accomplish great things or not, most times is not talent. It is just a reference. And look how crazy this is. Once MOVEdot started comparing themselves, not to other random startups, but to startups in San Francisco, we noticed, hey, we have to step up, we have to grow, we have to make hard decisions, we need to move. So it was just a matter of reference, really. And look how crazy this is, just for you to mirror yourself in great people and surround yourself and get inspired will change a lot. And the thing is, you should not be comparing even your teams to other teams alike. No, compare yourself to whoever won the competition last year. Or even more, compare yourself with teams outside. Of course, we will always use the excuse, but these other teams, they have more money. But that's not the point. The point is, I am totally convinced that you could be doing a lot better. That if you just follow their culture and mindset, you will do better. And if they have more money, go find this money. So this is the people that you should be comparing yourselves to. So go look at all of these teams on the outside. Try to think, what is the mentality behind that? Maybe you cannot buy that same carbon fiber wheel, but what is the mentality behind the decisions? For example, many teams abroad, they have 150 people. It is insane. They have a CEO, they have a CTO, they have a proper organization, and they can run this entire operation. Okay, you don't have the money. Do you need money to run people? Well, if you have a company, you do, because you need to pay salaries. In formal student, you don't pay salaries. So if you cannot manage a 150 people team, it means that the difference is not only the money, it's so much more than that. It's your mindset. So it was never about the talent, it's about who you're comparing yourself to and what dreams and goals you have. So think big, think in 10x, not 10%, or for those who are ambitious enough, thinking 1000x as well. So, is building a startup the solution for everyone who wants to accomplish something like this? Not necessarily, but this is not the point. The point here is not to start your own project necessarily. This is not for everyone. But no matter the work that you're doing, you can absolutely dream bigger, make hard decisions, and go act on it. Okay, excellent. So I wanted to now make it a bit more concrete. So I wanted to have us taking a look at a few examples. Now, speaking about AI specifically, like I said, the conversation was more about mentality. Now, speaking about specifically AI, which is what we do, what MOVEdot does, I wanted to share just a couple of examples of how AI can be beneficial in engineering. We could spend the rest of the day talking about that. We cannot, so I'll need to be brief. So, one thing important about AI, there are many different types of AI, right? There is the more traditional way, which is machine learning. What is machine learning? You have a neural network, which is basically a mathematical structure, sort of replicating how the brain works. And it learns something. This is why it's called machine learning. But in order to learn something, you need to give it a lot of data. So how does it work? Maybe you test your vehicle for thousands or millions of hours, and then you have all of these inputs. You have a black box, which is this neural network that gets trained in order to predict what the output is. So if you have a lot of data, you can train this black box, and then it will be able to predict the results. And this is good because lots of engineering courses at least teach a little bit about neural networks, but this is traditional AI. But then what happened? Some people in San Francisco, they built such a large neural network in such a specialized architecture that they were able to build large language models, LLMs, meaning ChatGPT, Gemini, and Claude. And those, they are so large that they are not just trained to do one thing, to predict suspension behavior. No, they are so large that they can interact similarly to a human being. These are LLMs, and these became AI agents. So all of the AI agents are sitting on top of an LLM, but then these LLMs, they start interacting with the real world. They can operate tools. They can run simulations. They can process data for you. They can create reports, plots, and so on. So this is basically how the technology progressed from a simple neural network with just a few layers of neurons, all the way to large language models, all the way to operating real human systems. And this became what we call AI agents. So what I'm focusing on today is not the only type of AI, but this is what our company does, which are AI agents. So how should you work with these LLMs and these AI agents? So you define the objective, so the input is always from you, so you need a lot of clarity of mind of what you're trying to achieve. The AI executes the manual work for you, you verify, and you decide at the end. And this is how you should think about AI in engineering. So maybe you have a request on the first one over there. You have a request, or you have a schedule, or you have an automation. Maybe let's say that you're working on a manufacturing plant, just to make it simple for everyone. Whenever new data comes from the production lines, you will trigger your agents. So your agents will start processing your data, writing Python scripts, calculating many KPIs by using your tools, potentially running simulations, testing different scenarios. And then you get the results, and then you can verify and approve them or not. But then, what we're really focused at MOVEdot, I don't want you to spend too much time here, is creating a flywheel around this. This is the whole concept that MOVEdot is bringing to automotive, which is the first time that you do an analysis, you really have to babysit or guide the agent. You have to explain the methodology, you have to correct the agent. But then the idea is, the agent should not be starting from scratch the next time. It should learn over time. So we're building this flywheel where every guidance that you give or any learning from the agent, it becomes stored and it becomes reusable. So our agents, they're documenting the work being done. We call this a self-wiki. We have background agents analyzing all of your interactions, all of the simulations that you ran, all of the analysis that you ran, and they are documenting this whole thing so that in the future, when you start it the next time, it's smarter. And then each time it's smarter, and the more people you bring to this system, it gets smarter. So this is one of the ways that we could be using AI agents in engineering. This is how our customers are using as well. We have customers in motorsports, some of the examples that I'm going to show you right now, and we also have customers in automotive, and then our goal is, over the years, start expanding this technology outside of automotive to aerospace, to manufacturing, and so on. So this is really our vision in the company. Now, let me show you the product. Usually I'm asking a lot more, or I'm asking you guys a lot more if you have questions, but I know that everyone is busy with the competition, so I'm trying to put out as much material as I can, and then at the end, as soon as we finish, you guys can continue to ask questions. So please take notes so that you don't forget. So let me open one example here to show you. All right, so this is our platform. We call it Move Center. So it's a platform where you can create all of your AI agents, you can connect all of your different data sources, you can connect your simulation software, and then you have an agent that you can interact with over here. I hope that my internet is good enough. But you can interact with this agent, give it a task, and then it's going to get it done. So let me show you this example. Here, we connected, so this is Formula 1 data. Another thing that we don't have in Brazil as much is this hack, as we say in English, this hacky mindset. I needed to create a great example for you guys and for other customers, but I cannot use customer data for that. But there are so many open source data sets on the internet. There are so many APIs that you can get this data. Take a look at this. We were able to get telemetry from Formula 1. Many of you might know this, might do that. We were able to get onboard videos and even the broadcast from the TV. in order to create this very cool example, and I have a bunch more just with open data sets. So it's very important. If you have the idea of running a project, just go do it. Go find data on the internet and go create the technology. So in this case, we connected with all of these different data sources, and the agent can analyze, pull the data, process the data, help you visualize this data, and even run simulations for you in order to validate these models. So there we go. So in this case, the agent is using the radio communication to understand that there was something happening here. For example, there was an overtake or an incident, and then it's finding the right time at the video where this happened from the onboards or from the TV broadcast. It is getting me the telemetry and the radio message over here, and it's collapsing that for me. So let me ask you, if you were doing this manually or the old way, how long would it take you to find every overtake in a Formula One race, get it from the radio, synchronize different sources of video, get the telemetry, and then crop the video for that? It would, if you're a very good engineer, it will take you a day. Most likely it will take you a week. But with agents, the agent can run this in 5 to 10 minutes. So remember when I said that 1000x? Can you see that this is a 1000x? Literally, you go from potentially 10 hours of work to 5 minutes. Someone can do the math for me, but yeah, maybe we're close to 1000x. And it is possible. And all of these ideas, they just came from me and my team learning on the internet, traveling the world, and implementing it. So there is no magic in creating it. It's very hard. You have to keep iterating. But basically here, the agent not only ran the analysis, but it created an app for us. So basically created a software that you can share with other people in your team so that they can consume the analysis that you did as well. So it's not a static thing. You can play this if internet allows. Let's see. There we go. So it's taking every overtake from Gasly here. You can play it. You can select another one. Let's take maybe another cooler one instead of the start. So times that it overtook someone, times that it was overtaken. So we can select this. There we go. So we can see Gasly being overtaken by someone else in 5 minutes. And basically you can, and this is synchronized with the telemetry. And I can click here on the telemetry and it's going to update for me where the video is. So you can run pretty much any analysis that you want. Let me show you another cool example, and then we have to keep moving on so that I can finish it in time. Let me show you another very cool example. So here, instead of consuming data, our objective was the following. We had a KNC software, so this is kinematics and compliance. It's basically a simulation, a suspension simulation software. And instead of me running analysis manually, I wanted the agent to run these analysis for me because it's faster and better. So this was the idea. It ran one simulation. Let me see if I have the example here. It ran one simulation because I also had real measurements from the car. This is something that I hope that you guys are doing. Using Optimum Kinematics from Optimum G, running a simulation, and then measuring your vehicle. There we go. Measuring your vehicle and comparing simulation with real data. This is ultra important. Anyone who will work with engineering should be doing this, okay? Because you're going to be using that. So, the idea here is the agent ran a kinematic simulation for me. It took real data that I had measured, it compared both, it identified the differences, and then it started adjusting my model until we can decrease these differences. This is simulation to real testing data correlation, super important. Very time consuming, so this is why we use AI agents to do that for us. But now we had a correlated vehicle model, meaning a model that we could trust. Instead of running the simulations manually, I set a workflow for the agent so that the agent could run this analysis thousands of times during the night. So it ran about 5,000. So first it did an analysis for me, what its sensitivity for a bump steer. It ran the whole analysis and gave me a report that I could review and give feedback. But then it ran 5,000 analysis for me during the night, and it fit a surrogate model for me. So remember what I mentioned about surrogate models? It's basically the black box, or the machine learning, or neural networks. So now that it had all of these 5,000 simulations over here, it could do what we call AI research, which is trying different methods to fit the surrogate model. So you see all of these different methods, and tell me for different sample sizes, let me scroll it down a bit, yes. So this is AI research. It's trying different methodologies to fit this, or to run this machine learning algorithm using different methodologies. And it's telling me, hey, if you're only running 100 simulations, you should be using this method over here, which is a neural network. If you're running 1,000 or 5,000, you should be using this other methodology. But really, you don't need more than 3,000 or 4,000 simulations, because more than that, you're not increasing the quality of the response of your model. This is called AI research. Before AI agents doing AI research, for me to run the simulations will take me a week. For me to do this study and report, it will take me another 2 weeks. So it would be almost a month. This would be probably a school project, like a long one. If not, probably a final thesis. And with the agent, I did this in maybe 3 days, 2 days. So it was 1 day teaching the agent all of the methodologies, 1 night running the simulations, the next day running this analysis, and there you go. So 3 days instead of a month. Once again, a huge gain. So this is another example. But then, if I want to see this result, so remember, fitting these models, there are many limitations. If you go design a new suspension, you need the kinematic software once again, okay? Because this is not physics. This is just predicting physics around the range for which you train this model. So what I did is, since this suspension was more or less fixed, we were only fine-tuning a couple of parameters. Instead of running each of the simulations every time that I wanted to analyze, I used this kinematic software. I ran all of the simulations ahead of time. I trained this surrogate model, this black box. And then what I could do is, I could ask the agent to create an app for me just to visualize the results. So instead of visualizing plots, I could ask the agent to create visualizations for me so that I could see the suspension performance. I can play with different parameters. And once again, it's not physics, but I used physics to estimate this. So you see how cool it is. It's AI agents using traditional AI to do some work for you. So these are some examples from our platform. We have hundreds of others, but I will need to continue. So this is a little example of what we were able to develop once we set our goals very high and we pushed very hard to achieve them. Great, I'm hoping that I can finish this very quickly. So, if we go back to the presentation, so a couple of examples on how AI agents and AI are being used in engineering, either with surrogate models or with AI agents. What else can you do with AI really in engineering? Now, who is using AI to develop software? Raise your hands, please. Guys, it's not enough. Everyone in this room should be building code, okay? We literally have people who never interacted with a line of code, now building entire websites and so on. And I know that looks silly when you speak about websites, but let me give you a few concrete ideas of what you should be doing. Whoever runs simulations, why are you still doing the simulations manually if you can automate the process? And obviously the physics model, you as the engineer, you need to master that, you need to write that, because it's the core product for you. But everything around it, automating the simulations, displaying the plots, this is peripheral. You should be using AI agents. Everyone here should be building code. There's so much leverage. And I don't mean this. I don't mean that you should become a developer, a programmer because of that. But you can speed up your work as an engineer by using code. And now you have an employee free of charge, or $20 a month. You just tell them what you want and they will build it for you. As I mentioned, automate engineering workflows. This should be done already by AI. Once again, it's not magic. It's not AI doing the work for you. It's you defining the objective, the AI executing the manual typing for you. Knowledge management. Who here is recording every call, every meeting, every conversation in the formal student team, using AI to transcribe it and keeping it in a central knowledge place? Guys, come on, one, please, one. Okay, no one. Guys, this is crazy. You should be recording every meeting. You can have like a microphone, you can literally record on your phone, on your watch, and then there are multiple applications where you can just put these meetings, you get transcriptions, and later on you can search that information. If you guys are still taking notes manually, you're losing a lot of time and a lot of information. There's so much, like it's very valuable for you to pay attention to the conversation and then be able to ask an AI, hey, what were the action items from this call? This is another 10x. You made it more, you enjoyed the presentation better or the meeting better, and then you have even more details afterwards. This is a must-do for everyone. What else? I'm curious to know, anyone has any other cool examples of what you've been using AI, LLMs, and agents for? Go ahead.
Do you want me to speak without the microphone?
Yeah, you can speak. Give the example.
Right. So what I'm using AI for is research that I'm doing. I don't know how I would say that in English.
A little closer.
Okay. Iniciação científica. I don't know how that would. Yeah, but I mean, a research so that we can use engine optimization with machine learning. So really interesting because I'm picking a physical model of the engine, gathering information of the engine as well, and use it as a parameter to make sure that if the data is correct and to create more data based on the one that we already have, and can put a model through that data and find, for an example, points of maximum of, I would like to have the maximum output of horsepower with the less amount of RPMs, for an example, and you can see that the maximum and minimums of the different variables of the equation as well.
Excellent. So this is a great example of building surrogate models, running optimizations on top of it, and basically doing AI research. And I'm sure that you use also AI to support with that. So it's very important that you guys find more ways in which AI can save time for you. Obviously, if the work is worse than what you do, then you don't use it. But in many applications, it will be a lot better. So automate the peripherals, go deep on what matters. The mathematical modeling in itself, if you're building anything in engineering. So another cool example, this presentation, it's not the best in the world, but I think it's cool looking, right? Do you guys like it? This will take me a week to prepare together with another engineer, and it would look a lot worse than this. Guys, it took me 1 hour and a half for everything, to think what I was going to talk about, to find the pictures, to build the presentation. I literally did this morning before traveling from São Paulo to here. 1 hour and a half. So another example of how AI is leveraging me. Because if I didn't have AI, I would not have the time to be here. I'm going on another trip very quickly. Today I'm going back to São Paulo for some more work with my guys. I will not have the time, and now I can. So it's AI allowing me to come and speak with you. And I created another one. So our company has a lot to do for the next for the next 2 weeks. We're going on a long trip where we're going to speak with 6 different automotive and tire manufacturers, presenting or running workshops with them so that they can experience this technology. It's a lot of work, so we had a lot to organize. I had to prepare a plan for everyone. Who is doing what, when. Okay, by the way, for the recording, I'm going to have to remove this part, just so I don't forget. We can blur it. But basically, this is the plan that we created. So where we're going to be in each one of the days, who is going to be doing what are all of the tasks day by day for everyone in the team, what are the priorities, which ones are not, And this is a lot of information. Take a look at this. So I was only able to manage this. It was in the middle of a crazy day, and I had to speak with the team about this. I did this whole thing. It said 3 hours. I think it was 2 because of AI. Otherwise, this would be a week of work. So what did I do? It's not only about using AI, it's about using it in a smart way. Well, we record all of our meetings, okay? So I didn't have to re-explain stuff to the AI. I took all of these different meetings with my co-founder, with the team, with different members of our engineering team. I put everything there. So all of our weekly recaps, daily stand-up meetings, and so on, everything was already context. I just said, this is the big picture, this is the trip that we're going to, this is what each customer wants, these are all of the tasks that we have to accomplish. Based on all of this information and my goals, and then I describe the goals, help me brainstorm, give me first a map of what is going on. It gave me a big picture map. Okay, finally I could understand. Okay, if out of these 1,000 tasks, these are the categories that we have, these are the priorities, these are the most impactful ones for this trip. Then I did another round. Okay, based on this, I would like to prioritize these, help me build the plan. There you go, I have this document, and then in 1 hour I reviewed everything with the team. Everyone knows what to do. Once again, 1000x gain of efficiency. And it was not me building this product, it's just about us being smart about how we use it. And can you start seeing how much you could be optimizing your Formula student work? Imagine if you had all of the meetings recorded, you would be able to ask the question of, every team has this problem. Where did we start drifting from the initial plan? Why did we not get the chance to test the car? What decisions did we make 6 months ago that really screwed us now? Or actually, the opposite, what were the decisions that we made? What were the priorities that we set correctly? What were the things that we cut that allowed us to get here with more than 500 kilometers tested, for example? It is so useful because when you go to the next year, you could have all of this information, and hopefully you would not repeat the same mistakes, and we just keep making the same mistakes every year, even though the information could be there if we did a better job of managing all of it. So I hope this gives you not only this example, but many other examples that you could be optimizing it. So how does this whole mindset, now wrapping up, how does this whole mindset plays out in Formula SAE? Am I telling you to go develop new technology? That would be cool, but I know that your focus is hopefully to come here and win the competition or win one of the events. So let's be a bit more pragmatic now, applying that to Formula student. What does it look like here, the 10x mindset? Have an ambitious goal, okay? So if your team never ran the car in the competition, you should come here to go compete in the endurance event and finish it, not less than that. If you come here and you finish the endurance, well, you should be coming here to win the competition, because if you're finishing the endurance, you actually have good chances of that. But the thing is, it's not only wishful thinking, it's not only, hey, I would love to win the competition. No, you're gonna have to do a lot of hard stuff to be able to win the competition. You have to get out of your comfort zone. You do need to make very hard decisions that really hurt you physically sometimes. Like you feel how much this hurts. Let me give you an example. I'm sure everyone here should have had a tough conversation during the year with a team member. Maybe there was someone that you should have let go of the team, that they should not be there anymore because they're just dragging you, they're not really contributing, and you didn't do. Why? Because you didn't get out of your comfort zone. Why? Because you didn't have an ambitious enough goal. When you have an ambitious enough goal and you need to win this competition, you have no excuses for not making the right decisions. So this is very pragmatic. I'm not talking about new technology. It's just about you learning how to deal with your mindset and be able to accomplish great things here. Now, a few examples now more technical. Design automation. So let me show you one example of a 10x that I did in my Formula student team. When I joined my Formula student team, we still used Atoms, which is very hard to use, at least for a Formula student team. And our guys were manually, or the last, obviously they did all of their 10x's, right? But where we stopped, when I joined, we were still manually, at least in the first year that I was there, we were still manually playing with pick points manually in atoms and hoping for the right height or for the roll center to be in the place that we wanted, or for the camber variation of the wheel to be in what we wanted. So my mentality, I think this is where I started building the 10x mentality was, okay, why do I have to play with the input to see the output instead of reverse engineering the process, defining an output, and then I automatically get the input. So this is what I did. I set this objective for me on my second year, and I did it. I created an entire automation using MATLAB, Excel, and CAD software, where you just said, I want this roll center height, this camber variation, this bump steer, this wheel track, whatever, and then it gave me the pick points of the suspension. So this is a 10x or a 1000x. So instead of, after I built this, instead of spending a month to define pick points, I spent maybe a day, and then I give to the chassis guy, and he says, hey, you need to adjust here. That's fine, I don't have to play with points. I just change a couple of the outputs that I wanted to give me the new pick points. So there are so many design automations that you guys could be building just by reverse engineering and not thinking in terms of inputs, but thinking in terms of outputs and how you get all the way back to the inputs. And obviously you need to study a lot of theory to understand that. So all of this understanding, it's not what AI should be doing for you, but once you understand this, I would have built this so much faster with AI because I wouldn't understand the methodology, but really writing the code and then creating the visualizations for it, I could automate so much of that. And I hope that you guys have a couple more ideas. Hopefully you have a couple of things that you accomplished in terms of 10x gains in Formula Student, and hopefully you will use this presentation to find a lot more examples. Cool, so maybe a challenge for you for Monday. By the way, the 2 years that our car broke during endurance, it was Monday. We were already at, not maybe at 8 a.m., but already at 10 a.m. in the workshop, preparing for the next year because we knew that we had to win this competition. So for Monday, you pick up manual process that your team hates. It could be management of information, maybe management of people, of knowledge. Describe it precisely, so understand, okay, what are all of the data sources that I need in order to accomplish this task? Is it just about organizing it? Do I need to go and learn something new in engineering, something new about my subsystem? Go describe exactly what this process looks like and how this could be improved. And just build, and engineering is about that. It's just have a good idea, or have a first idea. It's not going to be a good one, and then you keep building and creating around that. Get it done, do it every day, make hard decisions, do the tough conversations in the right way, learn from people, be humble, be ambitious, and then you'll be able to really get these 10x efficiency gains in engineering. So that is it for the presentation. Think 10x, let's go build. Thanks everyone for coming. And I'll be here for a couple of questions if you guys would like to keep discussing, okay? Thank you for coming. I know that everyone is busy. I appreciate you.